Going on, guys? Let's do this problem right here. The question is asking a large plate is pulled at a constant speed of u, that is equal to 4 meter per second, over a fixed plate on 5 millimeter thick engine oil film at 20 degrees Celsius. Assuming a half parabolic velocity profile in the oil film as sketched, determine the shear stress developed on the upper plate and its direction. What would happen if a linear velocity profile were assumed? So this is actually linear given, so we have to find the parabolic velocity. So what we can do, so the question is shear stress, right? The equation to find the stress is this, let's say rho is equal to mu dV by dH. So viscosity for oil is, so you have to look that one up in table, that is 0.8374 pascals second. So this is the viscosity of the oil, so we can apply that one right here. We have the height, that is 5 millimeter, but we have to find the velocity in parabolic, so let's find that one out. So in parabolic, we can calculate velocity by v square equal to ky. We know the v square here, v is equal to u right here. V is equal to u, so we can substitute that one for v, but yeah, so 4 meter per second, but we have to find the constant first. So constant, k is a constant, y is the height, so let's find the constant. So we have 4 square is equal to k times 5 times 10 to the power of minus 3, because it's in millimeter, I had to convert in meter. So this is going to be equal to what, 16 over 5 times 10 to the power of 3, and that's going to give us 16,000 divided by 5, and that is equal to that is equal to 3,200 meters square per second. So now we have the k constant we found out in using the linear velocity, right? But now we have to write the parabolic velocity. So to find the parabolic velocity, we can use the same equation, v square is equal to 3,200y. Therefore v is going to be equal to 56.568 square root of y, right? So this is the expression we are giving for the parabolic, and let's find this one right here. So let's apply all the information we have. We have mu and dV by dH. So dV, we calculate that one right here, that is 56.568 square root of y over dy, and that's, we can express that one as 37.712 mu times y. If I differentiate this one, that's, we are going to add one more power, right? That's going to be y3 by 2, and y is going from 0 to 5 times, y is equal to 5 times 10 to the power of minus 3. And from this one we can calculate this one. If I calculate everything, if I apply everything, it comes out to be 37,712 times 0.8374 pascal second times 0.0133, and that comes out to be 0.421 Newton per meter square. So this is the shear stress we have, and if we assume parabolic, and that's answer the first question. The second question is, what would happen if a linear velocity profile were assumed? Let's see what would happen. So we are going to use the same equation, that is, let's use the red color. Okay, rho is equal to mu dV by dy, right? And here what I'm going to do, mu we already know that's 0.8374, 0.8374, and u over h. Here we are assuming this one, so we can directly put that one right here. 4 over, we are assuming the linear one, so 4 over the height, that's 5 times 10 to the power of minus 3, and this one is going to give us approximately 670 newtons per meter square. And if you see the difference, this is when we assume parabolic, this is when we assume linear. The difference is huge, so therefore we can conclude that linear assumption is not realistic, since it gives over prediction, right? Gives over prediction. And that's the conclusion, and that's how it's done. I hope you guys like this video. See you next time.